A small object of uniform density rolls up a curved surface with an initial velocity n. It reaches up to a maximum height of 3v squared by 2g with respect to the initial position. What is that object? To determine the type of object, we can analyze the relationship between its initial kinetic energy and the height it reaches. Its given initial velocity as v and maximum height reached h is equal to 3v squared by 4g. When the object rolls up the surface, it converts its initial kinetic energy into gravitational potential energy. The initial kinetic energy of a rolling object consists of a translational and rotational kinetic energy, given by half mc square and half I beta square. Total kinetic energy of the rolling object is given by half mv square plus half I omega square. And according to energy conservation, initial kinetic energy is equal to potential energy at maximum height. So we can write half mv square plus half I omega square is equal to mgh, where m is the mass of the object, v is the linear velocity, I is the moment of inertia of the object, and omega is the angular velocity. Since v is equal to r omega, we can rewrite kinetic energy as half mv square into 1 plus I mr square is equal to mgh. At the maximum height h, all the kinetic energy is converted into gravitational potential energy. So, on plugging in h is equal to 3v square plus 4g, we get 3 by 4 is equal to 1 by 2 into 1 plus I mr square. And solving for I mr square, we get I mr square is equal to 1 by 3. So, the moment of inertia for a solid sphere is I is equal to 2 by 5 mr square. For a whole sphere is I is equal to 2 by 3 mr square. For a ring, I is equal to mr square. But for the disk, I is equal to 1 by 2 mr square. Hence, the correct answer is option C, this, because the value I by mr square is equal to 1 by 2 corresponds to its